Okay. So basically, we have this equation. I'm going to show you something. Put it in the calculator. So y equals 80 parentheses 4 to the x power. This is our graph. So you can see that, let's look at our table. Our y never gets to 0, even if x is negative. Okay? And we have all x numbers, and y just keeps growing, growing, growing. Okay? So it says, what is a reasonable domain and range for this? That would be C, because the x values are all real numbers, but we're looking at the population of the trees, and the population of the trees, that has to be a positive number, so the y has to be greater than 0. Now remember here, this 100 is the initial value. This 1/3 is the rate of change, and this t is the time. Okay, so let's see what it says here. The A value of 100 represents the original amount of medication, yes. And says the B value of 1/3 represents that for every 1/3 time interval t, the amount of, so we're seeing, is it a decrease? So it's not B. The A value of 100 times the B value of 1/3 is always the amount of medication that will remain. No. And then D says the A value is the time of medication at the time t, and the B value represents that it decreases every third of an hour. The A value is of, let's read A again. It says the A value of 100 represents the original amount of medication, and the B value of 1/3 represents that for every time interval t, the amount of medication decreases by a third. Yes, because this one's being more specific, every third of an hour. The number of bacteria colonies on a petri dish can be determined by this equation. So it says A, the final number, this is 5, once again, is our initial value, 2 is the rate of change, and t is the time. Okay, so A says the final number of bacterial colonies is found by multiplying the 5 original colonies by 2. That's kind of true, but we're forgetting the exponent there. When the observation began, there were 5 colonies, our initial value, and the number of bacteria colonies increased by a factor of 2 every time, and that is B. Okay, number 4. The number of milligrams of an antibiotic in a person's bloodstream, AH, is dependent on the number of hours elapsed since taking the antibiotic H. George took a 75 milligram dose of the antibiotic. So the 75, that is our initial value. And we have something to the H here, our time. 1 hour later, he had 15, so let's do our XY chart, milligrams. So at 1 hour, he had 70, or at 0.75. 1 hour, he had 15. 2 hours, he had 3. Okay, so we need, it's going to be a decrease. We need to figure out the rate of change. So 75 divided by 15 is 5. 15 divided by 3 is also 5. So let's say that this one is D, because 75 is our initial value there. Okay, number 5. 5 rodents were introduced into a zoo. Their expected population doubles every year. So 5 is our initial value. So we need a 5 here. And so it's not B and C, but it's not T to the second value. It's this way. We have the rate to the time. Okay, so number 6. The function y equals 2 times 3 to the x power is shown at the right. If the function is translated up 2 units, what will represent the intercept and the horizontal asymptote of the function? So then we're going to go up 1, 2. It's going to look like something like this. So the y-intercept is 0, 4, and this asymptote, hold on, I gotta ask Miss Bratton about that one. 7. The exponential function is graphed below. Which of the function is not true? So A says it's growth, and that is true. The y-intercept is at 0, 3. Yep, that's true. The graph has a horizontal asymptote of 2. Oh, yeah, the horizontal asymptote here. That's what I thought it was, just to be clear. Is this where it never touches, right there at 3. So it's 3. So the horizontal asymptote is 2. Yep, that's true. So it's going to be D. Okay, use technology to determine exponential function. Okay, so I'm going to do 0.81 divided by 0.03, and let's see what we get. Let's do 0.03. Hold on, I'm trying to figure this one out. Oh, 0.081 divided by 0.03 is 2.7. Oh, sorry. So we're multiplying by 2.7. Okay. And the initial value is 0. It says after 6 months, so we're going to do y equals 0.03 to 0.7 t. We're going to plug this into a graphing calculator. Let's see what it is. 0.03. Oh, let me clear that. Parentheses 2.7 to the x. Second table, it says 6 months. So it's 4.3 after 6 months it's 11.6. Okay, so on Monday, which is our initial value, this 3024 is our initial value. So with that said, we know it's not B and we know it's not D. So on day 1, there were 3024 people. Day 2, there were 756. And day 3, there were 189. Okay? 3024 divided by 756 is 4. So you're going down by 1/4. Okay? So that is A, because 0.25 is 1/4. And that is all.